Hey y'all, it's Sean Hominick. Welcome to Chasing in 2024, a technical forecast. I wanted to take a second to say thanks for watching the premiere of Chasing 2024, the video publication which came out just actually today. And I want to discuss a little bit about that. That's my first YouTube video and my first actual production, the initial premiere of that. And the whole point of it is for it to be a simple, sort of accessible breakdown of what's going on. In this case, it was of what makes storms cool, what makes storm chasing great, how supercells form, what they are, and then also a technical look into what's happening for the 2024 chasing season and what we can expect as we head out there this year. But there was a intentional lack of technical details so that folks can understand what we're talking about and make it a little bit more accessible for people. But being a nerd, as I am, a meteorologist, storm chaser, the focus obviously oftentimes is what goes on under the hood, behind the scenes. And that's going to be the point of this video, is to have a technical breakdown of what really is going on behind the scenes and look at what we're expecting for this year and the reasons why. So in this video, I'm going to discuss what went on this winter. So where are we? What's been happening for the last several months? We're going to look at local observations and regional and global observations right now. Look at sea surface temperature anomalies. Check out what's going on with El Nino, the transition to La Nina. Look at the latest analogs, overview the latest models, and also obviously provide that chasing forecast with a little bit more detail and commentary than we did in the other video. So a lot of really fun stuff coming up in this video. Let's get into it. So what did we experience this winter and what do we know so far? Well, first of all, and obviously the biggest headline is that this was one of the warmest winters on record in the United States. In fact, by the time we get through the rest of this winter, which is likely to be quite warm, we'll get to that eventually, it's probably going to be the warmest winter on record in the United States. The other thing is that it was wet in key areas of the plains and as well as on the East Coast, but a little bit drier in between. We can get into that. So let's go over and look at the temperatures. Here are the numbers. This is for the last 132 years. These rankings are showing you the winter ranking from essentially December 1st through the 20th of February. So for a vast majority of the upper Midwest, the Great Lakes, and the Northeast, this is a top 10 warmest winter. For much of Minnesota, Wisconsin, Michigan, even parts of Iowa, the Northern Plains, this is a top 5 or the warmest winter on record. So very, very impressive warmth. And then you have this string of cooler air that kind of runs underneath it from the Intermountain West into the Southeast states, where it was a little bit cooler than its surroundings. This is a fairly classic look for an El Nino winter where the warmth just flows into the central and northern third of the United States. And obviously we had a moderate to strong El Nino this year, and so this kind of makes a lot of sense. I mean, you never expect the warmest winter of all time. You do expect a warm El Nino winter, and that's what we had. So from a precipitation perspective, what did we have? And clearly it was very active across the plains. This is important for storm chasing, folks, because we need to build up this moisture as we go through the winter. Some of the worst storm chasing seasons we've had. We've seen severe drought ongoing in these regions, and we've seen prolonged dryness that is exacerbated during the winter months. We do not see that this winter. In fact, much of eastern Colorado, Nebraska, Kansas, Texas, and Oklahoma has been quite wet and very active during the winter. If we wind this back and look at the last 180 days, we can get a glimpse as to where the most significant anomalies are. And they're really from the Dakotas southward straight through the plains here. Essentially, the western and central plain states have been above normal in terms of precipitation over the last 180 days. If you do this over the last 90 days, look at this anomaly centered right what I would consider the key chasing areas if you're looking for supercells and great terrain. So we're off to a really good start during the winter. We've had quite a bit of moisture over the last 3 months in the areas that we want to see it. These are key areas that we want to keep moist as we head into the spring, and so far so good with that. But it's been a little bit drier further east. That's worth noting as well. And if we look at soil moisture to get an idea as to where we are on ground level, we see that it is wetter than normal in the Dakotas, near normal down through the central plains, and then here's this area of dryness. This is one thing we want to watch as we head through the spring and summer, is this dryness from Iowa through the I states into Illinois, Indiana, and then Ohio as well, Missouri obviously included too. This is not huge for storm chasing. It might become important down the road. bigger for agriculture, but definitely something worth watching. However, for the majority of our interests here, storm chasing wise, this winter has been about as good as you could ask for. It has been very wet throughout the central and western plains. The high plains have seen lots of moisture, and this is pretty much all you could ask for going into the winter and then emerging now into spring. So when we look at this in the mid-level height field, we look at 500 millibars and want to see how things played out. Here's the winter as a whole. You can only go through February 1st here, but here's December, all of December and all of January. And obviously the first thing that sticks out here, the eyesore, is this ridging and blocking pattern over southern Canada. So this ridge really was the catalyst for what we saw, those very, very impressive temperature anomalies across the northern plains and the northeast. So we had this sort of blocked up pattern. And then you have this troughing, this regime underneath it with an active sort of subtropical jet that was ongoing as well. You also have troughing in the Pacific. We've seen several times this year. We've seen a very excited Pacific jet, these impressive Pacific jet extensions. But let's break it down month by month, right? So we know we've had a warmer, active winter. This lines up and makes sense. But December, in general, featured a very impressive trough over Alaska extending out towards the Aleutians, and you had this sort of blocking ridge caught over in central Canada. This kept Canada extremely warm, the Canadian prairies very warm, but there really was a lack of significant, impressive cold underneath it, right? December was extremely warm. You just had this sort of subtropical troughing anomaly underneath here in Florida, and that kept this area a little cooler. We see that on those temperature anomalies we looked at earlier. Fast forward to January, and we have a more significant event going on here. We have blocking way up in the high latitudes, also in central and eastern Canada. And so that block that came up here north of Alaska, you see this dark red, that led to that Arctic outbreak, which was really the only true Arctic air we saw all winter when it came flowing down from western Canada and the Arctic into the central United States. It got very cold in the plains and in Texas, and eventually that moved to the eastern United States as well in late January. But when you average this winter out as a whole, the main feature was this blocking high and this blocking mid-level ridge that was over central Canada, and it kept a lot of the north-central U.S. warm, Canada warm, the northeast warm, and then you had this sort of troughing anomaly underneath. But no big, deep polar jet, no big, huge storms, winter storms at least, and this winter will end up going down as a very mild one, but quite active in the central plains because of this active subtropical jet. Now, the other thing that's happened all winter long is we have had a very weak stratospheric polar vortex. So when we look at the strength of the stratospheric polar vortex, we're looking at, what's going on way, way, way above where we are right now in the troposphere. But we've seen a very active up and down weak stratospheric polar vortex, but we have not seen yet that huge death blow to the stratospheric polar vortex, what we call a major sudden stratospheric warming or the final warming. When we look at the next couple days, it's weak, it strengthens again, goes back up towards average CLIMO, which is unbelievable considering how weak it's been, and then it drops off a cliff again, according to the GFS ensemble, to very, very weak values in the early to mid part of March. So the roller coaster continues, but the stratospheric polar vortex is probably going to come to the end of its life here and remain weaker than normal from mid to late March. So that gets you asking the question now. We know we've had an active blocky winter. We're getting into spring now. What's coming if the stratospheric polar vortex is going on this roller coaster ride? And the answer, I think, is going to eventually be more blocking. But let's get into what's happening before that. Here's a short and medium-term weather discussion, right? So we did our observations. We see where we've been this winter. Now, what's coming up in the short term? We have a jet in the Pacific that is pushing poleward and also retracting. So we've had a lot of long, extended Pacific jets this year, but much like when they extend, when they retract, they're kind of like a rubber band, or when you have a rope extended and you send that wave to the other person on that rope. When you retract the Pacific jet, all those waves are going to come out. So you're retracting the Pacific jet stream here in the medium range. Look at the waves now. See how wavy this pattern is getting, right? That is going to lead to the development of troughing on the west coast. When you have a poleward and then retracting jet like this, and maybe even a little bit of equatorward component here eventually with a subtropical jet developing, you are going to eventually bring troughs into the western U.S. And just look at how much this changes over the couple of days leading up to late February and early March. So this is a storm chasing discussion after all, right? If you look at this pattern in the Pacific and you're retracting that jet and you have a trough coming into the western U.S., you might want to pay attention a little bit here in early March, because what the models are suggesting is a very long jet coming in here, a deep trough with some subtropical connection coming into the United States in early March. This is southwesterly flow, folks, across the plains into parts of the Dixie Valley region and maybe the Mississippi and Ohio valleys during this time frame. It's still obviously this time of year to be determined what kind of moisture return you're talking about here, but a retracted jet is eventually going to send these waves out in late February and early March. And there will probably be a couple chances for severe weather, early season severe weather in the United States. That will be short-lived, though. We talked about that stratospheric polar vortex being weak, and what the models are eventually suggesting will happen is we'll start to get a pattern that's preloading this block. You see this big ridge building here? You have a storm digging into the Ohio Valley. That's going to pump up the heat flux here into eastern Canada and is going to start building ridging in the NAO region. If you look at the extended guidance, we follow the weeklies here with me. Look what they eventually do. They build that storm in, and then that turns into a negative NAO block here over Greenland, the Davis Strait, and central Canada. And so it's my opinion, given what we know about the very weak stratospheric polar vortex and the propensity for this pattern to get blocked up, that after this little window for chasing here in late March and early February, that we're going to go back to a colder pattern here for a period of time from probably mid to late March into early April. And the weeklies are very adamant about that. Anytime you have this troughing anomaly here on the East Coast and blocking here over Greenland, you can probably shut it down this time of year in terms of chasing. So that's step one. And step two of this pattern is we're going to get a little window. We're going to get the jet retraction. Some storms come out, some waves come through, and then we're probably going to reintroduce that block with that stratospheric polar vortex weakening. But it's not all bad news, because what this pattern will lead to eventually, in my mind, is a very favorable look for storm chasing as we head into April. So let's recap, right? We have two highlights here coming up over the next month and a half or so. We have a chasing opportunity from late February into early March. Still to be determined how this plays out, right? There might be some moisture concern issues, which is pretty common for this time of year, and we're still unclear exactly how these waves are going to come out. But the jet retraction is going to encourage those waves, at least two waves coming out from late February into early March, and the potential exists for chasing somewhere in the United States. After that, confidence is growing that blocking will come back at some point in mid to late March, likely lasting into at least early April. That's going to put the squash on the chasing chances there for a period of time, and likely going to lead to some colder air back into the United States as this block evolves. So those are two highlights here with the forecast into early April. That's when things start to get really fun. So I'm going to back us up all the way to spring of 2023, and I want to show you guys the pattern that we had in place as we went into April and May of 2023. So there's three regions that we want to watch very clearly and very carefully here that influenced the forecast last year, and then I'm going to fast forward to where we are this year. So the first thing we notice, at least in my eyes, is this warm blob in the North Pacific, this area of warm temperatures in the North Pacific and cooler waters along the west coast of the United States. This is known as a negative PDO, Pacific Decadal Oscillation. And the negative phase of the PDO simply has the warmer waters here in the North Pacific and then the cooler waters here along the coast. We're still in a negative PDO, but you'll see how different it is right now. The second thing we notice is the El Nino coming on strong late April and then into May. We see the El Nino building, so we had the increasing convection and the impact of the El Nino building during the spring of last year. And then we notice a positive AMO, which has been in place, and that's the Atlantic multidecadal oscillation, and that's warmer sea surface temperatures in the North Atlantic. So we have those three key things last year: negative PDO, building El Nino, positive AMO. Now, let's go to where we are right now. Obviously, things have escalated. We still have the positive AMO. We have what appears to be an El Nino, a strong El Nino in place built throughout the equatorial Pacific. And we have what I would call the remnants, or sort of a more elongated and broad negative PDO. If we go back again to where we were last year, this is more of a classic looking negative PDO, whereas what we see this year is much more broadened out. If we look by all technicality, we still are very much in a negative PDO. You see the oscillation operating here. As we go through, we are still in a negative PDO, but that value has come up quite a bit since where we were last year and where we were at the peak of this negative PDO. So still negative PDO by technicality. I like to use this graphic, which has been on the internet since like 1994. And it just shows you the difference between the positive and negative PDO. And you could see the negative PDO here that was in place last year and is still in place now by technicality. And we're going to operate as if we're in negative PDO here, but it's not as classic as it was last year with those negative anomalies sort of really focused over the North Pacific, south of the Aleutian Islands. So negative PDO, we still also have, again, as mentioned, we have the positive AMO and the El Nino in place. But what do we know about this El Nino going into this year? It's on its last legs, and that is going to be a key for this chasing season. If we look underneath the hood, what's going on underneath the surface is we have this building cold pool underneath. The subsurface temperatures are really getting chilly here, and you can see the sort of rising cooler temperatures underneath the surface. This is really indicating strongly now as we move into January and then February that the El Nino is on borrowed time here as we move into the spring. And most models agree with that. For example, here's the latest IRI forecast for the ENSO state. Just came out today, and you could see the drop from the El Nino that we're at now into La Nina by the time we get into the tri-monthly periods of spring and summer. This is May, June, July, and June, July, August. We are really at neutral on the ensemble mean by the April, May, June period, and then continuing into the summertime. So the speed at which this El Nino caves out is going to be really important for this chasing season. We're going to have uncertainty on this for at least the next month, month and a half. You can see the spread among the models here is already significant by the time we get into the next month and 2 months from now. So seeing how this plays out between now and the start of April is going to be a huge factor for this chasing season, and it's one of the main reasons I have zero confidence in how June plays out this year. I'm not even going to discuss June. There's too much mesoscale variability, and there's too much uncertainty with this pattern. That being said, we know a couple key things now. We know we have a weakening El Nino going into La Nina by summer. We know that we have a broadly negative PDO, we have a positive AMO, and we have this sort of broad warmth throughout the equatorial Pacific that underneath the surface is on borrowed time. So we can create analogs based on all these things, and that's exactly what I did. I went back and researched as many years as possible that had similar conditions to this. Here's what we found. All right, so here's the years that we got, and I'm going to start by showing you March versus the March forecast on the latest model guidance. I always say you got to know where you are before you know where you're going, right? It doesn't take long to figure out that these two things are pretty similar, right? We have, first of all, troughing digging through the west coast of the United States and then extending out to the east and into the parts of the Atlantic, and we have a high latitude blocking regime in March on the analogs up here into Canada and into the Davis Strait and up into central Canadian regions eventually of the Arctic. We also have a ridge south of the Aleutian Islands that appears and transient troughing up here into Alaska. So if we look just at this still image of the weeklies for days 10 to 40, which covers most of March, it looks very close to what we see on the analog. So we're feeling pretty good about where we are right now, right? We can even look at the weeklies and back them up a little for some comparison as we start March. This is the 30 days ending on the 25th, for example, and we very clearly can see that the weeklies are indicating that Aleutian Ridge here, which we see on the analogs, and then we have troughing coming down through Alaska and down into the west coast of the United States. So needless to say, when we look at this pattern, we feel pretty good about what the analogs are suggesting. And for March, what we see on the 30-day averages is that troughing extending into the east and that high latitude blocking going up into Canada. So far so good on the analogs. We're really close to this pattern that we see advertised for March, and the analog years are telling us that's what we should be seeing. So now let's get into the fun part and roll them forward to April, and boy, do things get exciting very quickly. First of all, we have a deep trough in the western United States, right? This blue is showing you where the troughing anomaly would be. We do see quite a bit of high latitude blocking. That's something to consider, but we also have ridging in the Great Lakes and the eastern United States. So conceptually, this is the kind of pattern that could be quite active during April, specifically the second half of April, because the way that I imagine this evolving here is that this block from March shifts westward and leads to some lingering cold air during the first half of April. This is probably, to me, a second half of April thing, but this is a good-looking map for April on the analogs, especially with this trough in the west coast and what we think would be a jet into the central United States. As we move ahead to May, this is when things get really exciting. I don't remember in my time, doing analog work and looking at long range forecasts, a more exciting chart than this for May when it comes to chasing. Obviously, this is just analogs. It's still a ways out, but the composite anomaly that we see here at 500 millibars is very exciting and would indicate likely a jet stream situated throughout the plain states and the possibility of a very active month from a storm chasing perspective. This is about as good as it gets with your troughing anomaly here. Now, it remains to be seen how the jet would behave, but this is a very good start if you're a storm chaser for April and May. Again, I got to specify, I think this is a second half of April into May thing once the blocking recedes, because you still do have quite a bit of blocking up here during April. If we look at even April, May, and June on these analog years, which were similar to this year so far, we have a trough oriented in the western United States, a big signal for a trough there, and ridging in the east. Again, the disclaimer, these are analogs. This is as close as we can get to this year, but every year is different. Each one of these analogs has a different outcome, and not all of these years were amazing for storm chasing. But when you look at where we are, the mean of these analogs, this is, obviously indicating the potential for an active season, not only for storm chasing, but for severe weather and tornado potential in the central United States. Here's the vector wind at 500 millibars. This kind of confirms what we thought, right? The models are showing the propensity for southwesterlies and anomalous winds jet stream through the plains, through the central United States, ridging in the east, and that return flow coming around it. And so the potential existing, matching up with what we see here for a very, very active season in April and May. And this is kind of the guiding force to the forecast from an analog perspective. Seasonal model guidance at this point, not going to be a huge help. We're still pretty far out there. I don't really like using seasonal models that much anyway, but let's see if we can find some confirmation of our ideas. We had an active April, right? We had troughing, some signal for troughing coming into the western United States here on the European. If we look at the monthly precipitation anomaly, hey, there's something, right? Very active across the plains into the Midwest, the Great Lakes. And this is a signal for an active month. Let's roll this forward into May. Again, very active, right? It's not often we see these models show very active wet weather. So this is a signal to me here specifically that the models are pinning the possibility of an active pattern, and that would line up closely with our analogs. Again, looking at the individual mid-level charts, it's not really going to help us that much, but we do have broad southwesterly flow here through the plains. Just a ton of variance on these models running, thousands of hours out. But still, it is nice to see, if we look at the monthly anomalies here in April and then in May, pretty active looking on the European seasonal. So we have our analogs, we have some model guidance, and we can start to put together our forecast. Here's what I've got for tornado season 2024. Okay, so here's the forecast. The orange and red is going to show you, or I should say yellow and orange, there's no red areas here, but that's going to show you where I expect more tornadoes than normal, also better storm chasing than normal, and the blue is less tornadoes than normal, and I wouldn't pay too much attention to that. It's just been so hyperactive here, and we know what the normal numbers are in this region. I do think that this year, specifically in April and May, which, by the way, this is when this forecast is for, that the tornadoes will be focused in two regions. First of all, in the southwestern plains, we've seen a lot of moisture here. We know we have a forecast for a very active pattern southwesterly flow. The idea here is that there will be several chances for supercells and tornadoes in this general region. And then the second region is up here in the Midwest. We've talked about, in the initial video, I referenced research that shows that during these terminating El Niños, when we're transitioning from El Niño to La Niña, that we get a secondary max of tornado potential up in this general region. A lot of the data, a lot of the synoptic forecast argues for two potential areas of locally higher tornadoes than normal. And that kind of builds this forecast. But honestly, in late April and May, the idea currently is that a lot of the plains will have the potential to see near or above normal tornado activity during this year. I think it looks like a pretty solid year for storm chasing. The disclaimers that we have to provide, obviously, are that it is storm chasing. These are mesoscale processes that are really difficult to forecast this far in advance. But when we look at the analogs, the synoptics, the global pattern, the models, of course, we add in at the end for guidance, all indications here are that the potential exists for a really, really good season for storm chasing. So let's review everything and wrap this up. Here are the highlights. We have one thing that's not on this graph, or this slide, I should say, is that we are expecting a small window for chasing from late February into March, early March. Then we get that blocking back, as we discussed, March, mid to late month into April, early April. It's the second half of April, late April into May that I expect activity to pick up and continue into May. Several chances for storm chasing. Could be focused on the plains. Hard to say exactly where things will set up, but looking pretty good. And then overall, I expect this to be a good chasing season. I think there'll be a lot of opportunities for whatever you're out there for, whether it be time lapses, cloud photography and stormscapes, or supercells and tornadoes. I think that this is going to be a good chasing season. All indications from this point are that it looks pretty good. Obviously, I'm going to leave you with this. This is a long-range forecast. I do my very best to try to forecast these things in advance, but subseasonal forecasting, severe weather, tornado forecasting is just unbelievably complex. We are learning as we go, and it's very tough. So we're going to review this as we go through. Hopefully everything works out. Either way, we're looking forward to it. Thank you guys so much for watching. This has been so fun to do these two videos over the last couple of days and weeks of work of putting this in, and I'm so excited for how they turned out. So with that,